In the name of God, the compassionate, the merciful. Hello, this is Ahmad Mirabi, and this is the third session of the Chemistry and Physics Core Topics course. In this session, we're going to cover the ionic compounds, naming and formula writing, and learning some polyatomic ions. Okay, what are ions? When an atom loses or gains electron, an ion forms. Metals usually lose electron to be positive ion or cation, and non-metals usually gain electron to be a negative ion or anion. For example, Na plus is a sodium atom which has lost one electron. It is called sodium ion. Okay, Cl minus is chlorine atom which has gained an electron. It is called chloride. I bring your attention to the IDE that is added at the end of the name of the atom, name of the element. So the name of the element is chlorine, but IDE is added, so the name is changed to chloride. This is how we name the anions or anions. An IDE will be added at the end, but in the case of cations, nothing changes. We just call it sodium ion. Okay. What is ionic? Let's talk about ionic compounds a bit. When a metal which has a tendency to lose electron combines with a non-metal which has a tendency to gain electron, one or more electron transfer from metal to non-metal, creating a positive and negative ions that are attracted to each other. So here electron transfers. We in covalent bond we said electrons are shared between atoms, but in ionic compounds electron is transferred from one element to the other. It is usually from metal to non-metal, because metals want to lose electron and non-metals want to gain electron. We'll talk about it later again. A compound composed of metal and non-metal is considered ionic. The basic unit of ionic compound is a Fermi unit. I mean, it's not a molecule. Ionic compounds are not molecules. The basic unit of ionic compound is Fermi units. Unlike molecular compounds, ionic compounds do not contain individual molecules, but rather cations and anions in an alternating three-dimensional array. So this is the way ionic compounds will be formed. Let me write down some the way ionic compound will be formed. Let me write it here. For example, if we consider the sodium ion here, we will have a chloride ion here. The size is a bit bigger. Chloride again here. They attract each other because of electric attraction. Negative charge and positive charges attract each other. So each sodium ion will be neighbored by 6 chloride ions. Right, left, up, down, and one at the one in front and one in the back. I mean, each sodium ion is neighbored by 6 chloride ion, and vice versa. Each chloride atom is neighbored by 6 sodium ion. This is the way ions will be placed one next to each other. So here we'll have a sodium ion Again, here we'll have a sodium ion. Again, we'll have a chloride. And then it continues on, and it forms a great lattice, and it forms a great lattice of ions. So in ionic compounds, will not have a molecule. The building block of an ionic compound is not a molecule. Okay, let's continue. Let's go to periodic table. In periodic table, we learned that the first group elements have one electron in the outermost shell, and if they lose one electron to become a positive one ion, they will be like noble gases, which is a stable condition, which is a stable state in elements and atoms. So that's why the first group elements will lose one electron. So again, we see that everything goes back to electron configuration. If we know the electron configuration of an atom or element, it is understandable that why, for example, Mg will become Mg2 plus, and why calcium will be calcium 2 plus, and not no any other ion will be formed. Group 2 elements, except beryllium, will be 2 plus ions. Why halogens, which are in 17th group, form one negative ion? Of course, H minus is sometimes this happen. Sometimes hydrogen will be a negative ion, but halogens starting from fluoride, fluorine, chlorine, bromine, and iodine will be negative, one negative charge, will be one negative ion. Why? Because in the outermost shell they have 7 electrons, and they want to gain 1 electron to be stable. So understanding the periodic table and understanding the electron configuration of elements is the key to understand why these ions will be formed like this. Okay, so in the 7th group elements will be which are called halogens, will be a negative 1 ion. 16th group elements like oxygen, sulfur, selenium will be negative 2, will form negative 2 ion. Only negative 2 ion, and oxygen sometimes will form a peroxide, of course, but most of the time this is the case. Nitrogen and phosphorus in the 15th group, or 5th main group, will form negative 3 ion, because there's a distance of 3 between the 5A and 8A group. Aluminium is a metal in the 3rd main group. It always form a positive 3 ion. Zinc and silver are metals in the transition metals. These two also form fixed charge ions always. For example, silver always will form a Ag plus ion, and zinc always form a Zn2 plus ion. But there are other transition metals like iron or copper or mercury. So many others will have some different will form some different ions. They will have different charges. For example, copper 1 and copper 2. We have 2 copper. Okay, so these are the elements which have a fixed charge when become ion, predicting charges on monoatomic ions. So these, for example, we know that if an element is in the first group of periodic table, it will be only and only 1 positive charge ion. It will form 1 positive charge ion. We'll never have a sodium 2 plus. We'll never have a sodium 2 plus. Sodium is always If it becomes ion, it will form a Na plus ion. Okay, so we're reviewing the monoatomic ions again here. H plus is hydrogen ion and lithium ion, sodium ion, and as we said, in the positive ion or cations, naming is easy. Cesium ion. Of course, beryllium won't form an ion. It's an exception. We'll talk about it later in 10th grade or 11th grade. Magnesium, these are group 2 elements. So magnesium ion, calcium ion. Of course, I bring your attention to Ag, which is silver, Ag plus, and we can say, of course, we can write down here Zn. Zn is always 2 plus, so it is a zinc ion. Okay, and going to negative ions, H minus is hydride. Pay attention to the IDE, which is added to the negative ions or anions. Fluorine will become fluoride, chloride, bromide, iodide, oxide, and sulfide. For example, if I want to write nitrogen, I know that nitrogen is in the 15th group, so it will be a 3 negative, it will form a 3 negative ion, and the name is nitride. This is important. Okay, let's go to the next slide. Naming positive ions. Before you name an ion, you have to know the charge. So we talked about it in the slide of periodic table. We said group 1 elements always positive 1 will always form a positive 1 ion. Group 2 elements will always form a positive 2 ion. Aluminium always positive 3, zinc and cadmium positive 2, and silver always form a positive 1 ion. We need to memorize. As I told you, we need to memorize the first 20 elements. We need to memorize the halogens. For example, we need to know fluorine, chlorine, bromine, and iodine are halogens, or sodium, potassium, lithium, sodium, potassium, cesium are group 1 metals. We need to memorize some of them. This is the building block of chemistry. Okay, with group 1, 2, aluminium, zinc, cadmium, and silver, we just give the name of the atom. So, for naming the positive ions or cations, the naming ion is easy. Nothing will be added. So Na plus is sodium ion, Mg2 plus is magnesium ion. That's it. But for negative ions or anions, an IDE will be added. All negative ions have their ending changed to IDE. Oxygen becomes oxide, fluorine becomes fluoride, nitrogen becomes nitride, chlorine becomes chloride. Of course, we call this chloride, but if we have Cl alone, this is chlorine. This is chlorine element. And if we said chlorine alone, without mentioning if it's an element or atom, chlorine means Cl2, because we know that chlorine in nature, chlorine will be found in nature as Cl2, as a molecule. Okay, so chloride is Cl minus, nitride is N3 minus, and so forth. Let's go forward. Formula of ionic compounds. Formula of ionic compounds are determined from the charges on the ions. So sodium has 1 electron in the outermost shell. Fluorine has 7 electrons in the valence shell. That's why sodium loses one electron and fluorine gains one electron. Both of them will be like noble gases, will be stable like noble gases. So sodium ion and fluoride will form a ionic bond, and the formula of a unit will be NaF. I bring your attention to the positive 1 charge and negative 1 charge, that they will cancel each other and the total charge will be 0. The total charge of a formula unit must be 0. I emphasize that NaF is not a molecule. NaF is a formula unit for a giant lattice of ionic compounds, which is sodium fluoride. Write the formula for the ionic compound that will form between barium 2+ and chloride. To cancel out barium's positive 2, then 2 -1 chlorides are needed. Or 2 -1 chlorides are needed. Balance charge with positive and negative ions. Write the positive ion metal first and then the negative ion. We always write the positive ion or cation first and then the negative ion. So we say because barium is a positive 2 ion, barium belongs to second group and chlorine belongs to 17th group, or chlorine is a halogen. So Cl- and Cl-, so 2 chlorides are needed to balance the charge of positive 2. That's why we write down BaCl2. This 2 is needed to write the formula unit of barium chloride, so that this formula unit is electrically neutral. Write the number of ions needed as subscripts. Okay, every ionic compound should have a formula that has a charge that equals 0. Bring barium fluoride as another example. Barium is 2+, fluoride is -1. So 2 fluorides. How many fluoride are needed to balance? 2. So the formula will be barium fluoride, BaF2. This 2 is needed for the formula unit to be neutral. Another way is swapping the charges and then simplifying. For example, in the aluminum oxide, aluminum has a positive 3 charge and oxide has a negative 2 charge. We swap the numbers. We'll give the charge of aluminum to the oxygen. We'll give the charge of the oxygen to the aluminum, and then if acceptable, we simplify it. In the case of magnesium oxide, we swap the charges again, and of course, can we simplify it? Yes, we simplify it to write MgO, because 2 and 2 will be simplified, because it's not a molecule. Mg2O2 is not a molecule. MgO is not a molecule. This is just a formula unit for a lattice of ions. So it's better to write MgO, which means 1 Mg and 1 oxygen. The ratio of number of magnesium to oxygen is 1 to 1. That's it. Okay, let's do some practice here. Which is the correct formula for the compound containing the following ions? So a compound that has sodium and sulfide will be Na2S, right? Because 2 sodium is needed to balance the charge of a sulfide. Okay, so let me tick this one. And another one, number 2, aluminium and chloride. So 3 chloride are needed. 3 chlorides are needed to balance the charge of aluminium. So AlCl3 is needed. The name is aluminium chloride. No no number is needed to name it. Aluminum chloride, that's it. Number 3, magnesium ion and nitride. So we need 3 magnesium and 2 nitride so that they cancel each other. So Mg3 and 2 will be the correct choice. Or we can say we can swap the charges and then write the formula. Because if we take 3 magnesium, it will be positive 6 charge, and 2 nitride has negative 6 charge, so this way they can cancel out each other. Okay, binary ionic compounds. Cation first, or cation first, and then anion. Anion is a negative charge, cation is a positive charge. Monoatomic cation, name of the elements. Monoatomic anion, root plus IDE. So chloride, as I mentioned earlier, we add IDE at the end of the root name. So to name a binary ionic compound, we first name the positive ion or cation, and then name the anion. So calcium chloride. As another examples, here we have the metal first, or positive ion first, or cation first, and then we call the anion or negative ion. So sodium, the name of NaCl is sodium chloride. The name of ZnI2 is zinc iodide, and the name of Al2O3 is aluminum oxide. Okay, so let's do some practice. Complete the name of the following binary compounds. Binary means 2, which means positive ion is 1 element, negative ion is 1 element. So we have only 2 elements in the compound. So let's complete these one. Sodium, okay, what is the negative ion here? It's an N3 minus, so it's nitride. So let me write here nitride. Is it different from nitrate or nitrite? Yes. Nitrate and nitrite is something else. We'll cover it in this session. But nitride, I emphasize on IDE, which needed to be added at the end. Okay. Potassium bromide. Potassium bromide here. What about the other one? Aluminum oxide. And the last one, this is magnesium sulfide. I emphasize on IDE, which we need to add at the end, and we need to name the positive ion or the metal first. Okay. Transition metals, elements that can have more than one possible charge, must have a Roman numeral to indicate the charge and the individual ion. So we know that some ions in the some elements in transition metals have more than one, will form more than one ion or have more than one charge. For example, we have copper 1 ion and copper 2 ion. So to indicate these two and to show which one we meant, which one is meant, Roman numerals are used. So I for 1, II for 2, III for 3, and IV for 4. You know how we use Roman numerals, right? So for iron, again, we have 2 possible ions, iron 2 and iron 3. So when mentioning the iron element or copper elements, we definitely need to write the Roman numeral. Let's see some examples. These elements require Roman numerals because they can have more than one possible charge. Anything except group 1A, which is first main group, 2A, or second main group, which are magnesium, calcium, barium, silver, zinc, cadmium, and aluminium. Anything except these will have, of course, zinc is included in here. Some elements have two or more than one possible charge. You should already know the charge of these. We need to know the charge of first group elements. We need to, for example, if we name sodium, you need to say that, you need to know sodium will always be a positive 1 ion. When we say potassium, you need to know that it always be a 1 plus 1 ion, and lithium again 1 plus ion. Magnesium is in the second group. Calcium is in the second group, which is the 20th element. Another example is barium. Barium is in the second group. When we talk about fluorine, chlorine, bromine, and iodine, which are the halogens, all of them will be negative. We don't put the negative 1 because it's we simplify and we don't write the 1 here. So F minus is the same as F minus 1, and Na plus is the same as Na plus 1. So we drop the 1. So Br minus and I minus. So fluoride, chloride, bromide, iodide. But if copper is mentioned, or if iron is mentioned, we need to write a numeral. We don't know what charge of copper is involved or what charge of iron is involved. And for mercury is again the same thing. For lead is again the same thing. We'll see some examples to know which elements have this property. Copper, iron, mercury, lead are some examples of transition metals with more than one ion. Another way to say it, transition metals and metals in group 4A and 5A, except silver, zinc, cadmium, and aluminium, require a Roman numeral. For example, FeCl3. Okay, we understand from the formula that it is a Fe3+, so the name will be iron 3 chloride. CuCl, so we understand from the formula because the anion is chloride, so the cation must be Cu1+. So from here we understand that Cu1+ or Cu+ is involved. So the name would be copper 1 chloride. This Roman numeral is essential and needed. If we don't write this Roman numeral, the name won't represent this formula. SnF4. Sn is 10, which is in fourth group. Sn4+, so we understand from the formula that it is Sn4+, so the name is tin 4 fluoride. PbCl2, again Pb2+ and lead 2 chloride. Fe2S3, so we understand from the formula that it is Fe3+, so we call this formula iron 3 sulfide. I emphasize that these are not molecules. This is not a molecule, this is a formula unit. Okay, complete the name. Let's do some practice. Complete the name of the following binary compound with variable metal ion. So I need to write here iron 2 bromide, right? How did I understand that it is iron 2 but not iron 3? Because we know that the anion is Br1 minus, so it must be Fe2 plus, so that the formula will be FeBr2. Okay, and the copper here, the copper will be copper 1 chloride. Now let's name the next one. Sn is tin, and we have O, which is oxide. What is the Roman numeral I need to use? The Roman numeral is 4, because I know that oxygen has a -2 charge in 99% of in 99 percent of the compounds, oxygen will form a -2 ion. Sometimes it will form a -1. That we will cover it in other grades in chemistry. Okay, so here we understand that tin must be 4 positive charge, so it is tin 4 oxide here. Let's continue with the other one. This is iron. This is iron 3 oxide, and because the charges are swapped here, and this indicates that iron 3 is being used. This is mercury sulfide. Sulfur is in the 16th group of periodic table. Just like oxygen, it forms a -2 ion. So here mercury must be +1 ion to form this compound. So we call it mercury. So we call it mercury 1 sulfide. Okay. Some ions are composed of more than one atom. These are called polyatomic ions or multiatomic ions. For example, in the case of NO3 minus, the whole thing is a negative ion or an ion. The whole thing is a negative ion. This is called nitrates. This is called nitrate. We need to know the name of some of these polyatomic ions. For example, SO4 2 minus. SO4 2 minus is SO4 2 minus is named sulfates. SO4 2 minus is called phosphates. We need to memorize the name of these polyatomic ions. SO4 2 minus has 4 atoms in it, 1 sulfur and 4 oxygen. The whole thing, the whole thing, 1 sulfur and 4 atoms of oxygen are connected to each other, and it has a -2 charge. So it's a multiatomic ion or polyatomic ion. I'm sorry, this is the name is because it has a sulfur here. It is called sulfates. It is called sulfates. I was disrupted by some messages, and of course PO4 3 minus is called phosphates. This is called phosphates because we have phosphorus here, and phosphorus phosphate, sulfur sulfates. Okay, let's go back to the slide. These are called polyatomic ions. Poly means more, or we can also call multiatomic ions. The examples are NO3 minus nitrates, SO4 2 minus, SO4 2 minus. In chemistry we write 2 first. SO4 2 minus is called sulfate. And for example, if we want to have a ionic compound with silver ion and nitrate ion, silver ion is a positive one, nitrate is a negative one. So we'll have, as we said earlier, we write the positive ion first and then the negative ion. So AgNO3 is silver nitrate. Copper 1 sulfate, copper 1 and sulfate here, so we need a subscript of 2 for copper, so that this formula unit is neutral. Okay, lead 4 phosphates is another example. Lead 4 is Pb4 plus and phosphate is PO4 3 minus. It's better to write PO4 3 minus. In chemistry we write down the number, when we want to write the charge of an ion, we write the number first and then the negative or positive. For example, in the magnesium case, we write the 2 plus, not positive 2. Okay, it's not important very much, but it's better to write this way. Lead 4 and phosphate, so we swap the charges. 4 here comes here and 3 comes here. Lead 4 phosphates. Lead is among the transition metals which has some different ions. We'll have some different ions, so a Roman numeral is needed. When more than one polyatomic ion is present, you surround it with a parenthesis. So in here we need to put a parenthesis here so that we say this 4 belongs to the whole atoms inside this negative ion or phosphate. The subscripts on polyatomic ions are never changed. It means PO4 will remain PO4 because it's phosphate. The subscript 4 for oxygen is belongs to the phosphate, so this subscript of 4 for oxygen will not change. Okay, let's do some practice here. We have write the correct formula for the compounds containing the following ion. I do this and then name the compound also. So sodium, we have sodium ion here and we have phosphate. So how many sodium ions are needed to neutralize this compound? 3. So I will choose choice C because 3 sodiums are needed to balance 1 phosphate. So the name will be sodium phosphate. I'm not sure if F is needed here or pH. And never mind. Aluminium ion and nitrates. So how many nitrates are needed? 3. 3 nitrates. So I choose choice A because 3 nitrates, 3 is swapped here to be a subscript of nitrates. So the name is aluminium nitrates. In the number 3, this ion is called ammonium. I'll write down the list of polyatomic ions in the following slide. We'll see them. So NH4 plus is ammonium and N3 minus is nitride. So 3 ammonium is needed to neutralize this. So choice C is correct. The name of this compound is ammonium nitride. Is it nitrate or nitrite? No, It is nitride because it is monoatomic. N3 minus. N3 minus is nitride. But NO3 minus is nitrate, and we'll learn how NO2 minus is nitride. It's called nitride. Okay. Name of some polyatomic ions here. Acetate is C2H3O minus, or it can also be written like this: CH3 COO minus. It can also be written like this. I think 2 oxygen is needed here. 2 carbon, 3 hydrogen, and 2 oxygen. Yeah, this is called acetate, which is an organic ion. We learn this more in organic compounds and organic chemistry. Carbonate is CO3 2 minus. Chlorate is ClO3 1 minus. As I told you, we can drop the 1 here. We can say ClO3 minus. Cyanide is Cn minus. Hydroxide is OH minus. Nitrate is NO3 minus. Peroxide is O2 2 minus. This is a very rare case when oxygen will be a -1 ion, not a not -2 ion. 2 oxygens will be -2. Phosphate is PO4 3 minus. Yeah, pH is needed here. Sulfate is SO4 2 minus. Ammonium is NH4 1 plus. Okay. Most polyatomic ions end in 8. The ending ITE means 1 less oxygen present in the ending. For example, nitrate is NO3 minus and nitrite is NO2 minus. Okay. To name one more example, SO4 2 minus is sulfates, and SO3 minus, SO3 2 minus, the charge doesn't change. The charge is -2 and -2. Here the charge is -1, the charge is -1, here is -1 again. Okay, this is called sulfides. So 1 oxygen is less, the name is changed from ATE to ITE. The same case applies for phosphate, PO4 3 minus, and PO3 3 minus, which is phosphite. And the same case applies for ClO3 minus, which is chlorate, and ClO2 minus, which is chlorite. So this is chlorite, and this is chlorate. Okay. Only the number of oxygens changed, not the charge. The charge won't change. 2 minus, 2 minus, 1 minus, 1 minus. The charge doesn't change. So let's review some properties of ionic compounds. Ionic compounds are also known as salts. A very typical example is NaCl, which is the table salts, edible salts. They are usually hard and brittle, so the ionic compounds are hard and brittle. Conduct electricity when molten or dissolved. When molten or dissolved, the ions will separate from each other, so the presence of ions in a solution causes the solution to conduct electricity. Have very high melting and boiling point because the force applies between the elements, or between the particles, the force applied between the particles are strong electrical forces. It is difficult to separate the ions from each other. That's why it has a high melting point, boiling point. For example, in the edible salt, it is, I think it is above 1,000 degrees Celsius, if I'm correct. But I think maybe it is 300, something like this, or I'm not sure, but I know for sure that the melting point and boiling point is very high compared to 100 degrees Celsius for water. The melting point, the boiling point of water is 100 degrees Celsius compared to the melting point of the ionic compounds. It is very higher. Most are soluble in water. Most of the ionic compounds are soluble in water. For example, AgCl, or silver chloride, is not soluble in water. This is one case. Or silver halides are not soluble in water. Silver bromide is the same thing. Silver iodide is the same. They are not soluble in water, but most of the ionic compounds are soluble in water, normally composed of at least one metal and one non-metal. So even if polyatomic ions are used, normally and usually it has composed of at least one metal and non-metal. Sometimes it is normally, but not always. For example, we have a compound called ammonium nitrates. So in the case of ammonium nitrate, both the positive ion and negative ion, which is nitrate, none of them has a metal. All composed of non-metals. So NH4 plus is ammonium, NO3 minus is nitrate. So this is an exception to this, but we've said normally and usually. Okay, it's enough for this session about ionic compounds. From the next session we'll start physics.